Welcome to this next lecture on acoustics. Today we will be looking at the 1D acoustic wave equation. It's given by del 2p by del x square is equal to 1 over c square del 2p by del t square. We can put a tilde. Okay. Now we have seen this form several times now. So the solution is p tilde x comma t is equal to a tilde e to the power of minus jkx plus b tilde e to the power jkx e to the power of j omega t. So if we have to see this pictorially, there is a pipe, let us say, this is the x direction, and it is somehow driven on this side by a piston or a speaker, and there are waves propagating, there are compression waves, and there are rarefactions, expansions. Okay. But these are planes, okay, these are planes in the sense along the plane, along this plane there are no variations of any parameter. Only variations happen in the x direction. So these are called plane waves. Plane waves. Now typically what happens is that either you have a very long pipe or a pipe with a finite length, but on one end it is excited or driven by a speaker or some source, acoustic speaker, okay, source, okay. We call it a volume velocity source, call it a volume velocity source. So it's modeled by a piston that moves back and forth, or the physical reality of that is a piston that moves back and forth, or a speaker cone that moves back and forth, so that it puts in a volume velocity and it takes back the volume velocity in a harmonic fashion. Now the very useful equation for us, a very useful equation for us is the Euler equation, okay, Euler equation, which is del p tilde by del x is equal to minus rho 0 del u tilde by del t. So this relates the pressure gradient to the acceleration, and in the harmonic case this is very useful. In the harmonic case it is very useful, okay. Why? Because in the harmonic case u tilde is some u0 or ux e to the power j omega t, so that this now becomes minus rho 0 j omega ux e to the power of j omega t, okay. And similarly p on the left hand side is given by this, p on the left hand side is given by this. So what we have now is if I take del p del x, I get minus j k a tilde e to the power of minus j k x plus jk b tilde e to the power jkx. Now if we say that the k is omega by c, then we have minus rho 0 c u of x, and there is this temporal term here also which we take out. So this right hand side is equal to, j goes off also, j we cancel, okay. So minus a tilde minus jkx plus b tilde e to the power of jkx. Or if we take out the minus also, what I get is u of x, the amplitude of the particle velocity at any point x, is equal to a tilde by rho 0 c e to the power of minus jkx minus b tilde by rho 0 c e to the power of jkx. Okay. So now we immediately have the particle velocity, which means what? If my pressure is given by let us say a e to the power of minus jkx, let me keep the time, that is a right going wave, plus b tilde e to the power of jkx, which is a left travelling wave, e to the power of j omega t, okay, this is a left travelling wave. Then the particle velocity into e to the power j omega t, let me put it, is a tilde by rho 0 c e to the power of minus jkx minus by rho 0 c e to the power of jkx e to the power of j omega t. Okay. So you can see that if I have a tilde positive, okay, then it's a compressive wave, and the corresponding velocity, corresponding particle velocity, the corresponding particle velocity is a tilde by rho 0 c. From all the signs it's towards the right. Okay. Similarly, if b tilde is positive, then it is also a compressive wave. However, it is left going, okay, it is left going. And hence the particle velocity, So it's a compressive wave moving towards the left. So this is a compressive wave moving towards the right. Okay. So this is a compressive wave moving towards the left. So this here is a compressive wave moving towards the left, and so my particle velocity will be negative. Okay, it's this positive number b tilde compressive rho 0 c with a minus. That's what is shown over here. Okay. So that's how the pressure and particle velocity appear in a 1D wave, 1D acoustic wave. And we have to figure out A's and B's based on boundary conditions. Okay, that's the idea. So now let us look at a situation or a system here is a system. It's a finite length. So let me go to the next page. It's a finite length pipe or a duct. Some people want to call it a duct. Okay, and there is again some mechanical impedance at the end. And here it is driven by a piston. Okay, a volume velocity source. Q0 e to the power of j omega t is the volume velocity, and this is a finite length duct. This is the x0 position, this is the x equal to L position. Okay, Q0 is the volume velocity. Okay, volume velocity source. So now if I take my solution Px comma t, and let's say the cross section area is S. Plus b tilde so we need two boundary conditions. Okay, so one boundary condition, what is it? At x equal to 0, okay, the particle velocity at x equal to 0 is this volume velocity e to the power j by the cross section area. Okay, so this has volume per unit time units. Q0 has volume per unit time units. Okay, Q0. Okay, so Q0 divided by S cross section area has L over T units, which is velocity. So that's the condition at the left end. Okay, and what about the right end? At the right end I have pressure at the right end multiplied by cross section, which is force, divided by V tilde at L, okay, is equal to the Z mechanical. So I will remove the time also here. Please remember, this is always a problem. Okay, when to keep time, when not to keep the time, because anyway it's harmonic. So one should do it with understanding. So now let's look at this. Okay, so we have at x equal to L we have at x equal to L, the pressure L, let me keep the time, S into cross section force is equal to Z mechanical tilde into velocity at L comma t. How do we get velocity? From the Euler equation. And what does Euler equation say? Del p tilde by del x is equal to minus rho 0 del u tilde by del t, or minus j omega rho 0 u tilde. Okay, so so if I divide by C, and I multiply by C, then I can write it as minus j k rho 0 C into u tilde, the particle velocity, okay, x comma t. So now what happens at the right hand end? If we want to do this, I want this particle velocity, okay. So p tilde L comma t into S is equal to Z mechanical tilde del p del x 1 by minus j k rho 0 C del p by del x at x equal to L. Okay. So now please bear with me when it comes to the time issue. I'll conveniently keep and remove e to the power j omega t, otherwise it becomes too cumbersome. So pressure at L, okay, without this temporal term, is A tilde e to the power of minus j k L plus B tilde e to the power j k L. Okay, let me keep the time into S, that is equal to this mechanical impedance at the end divided by minus j k rho 0 C, then del p del x, again from here we compute del p del x. Okay, so del p del x is minus j k A tilde e to the power of minus j k L plus j k B tilde e to the power of j k L, and I'll keep the time, I said, okay. So now what happens? If I cancel the j k bit now, Z m L tilde by rho 0 C, if I cancel the minus j k, A tilde e to the power of minus j k L minus B tilde e to the power of j k L, and I'll take out the time, okay. As I said, it's a cumbersome to carry that all the while, okay. So what if I bring this to the other side? I have A tilde e to the power of minus j k L plus B tilde e to the power of j k L by A tilde e to the power of minus j k L plus b tilde e to the power j k l into s is equal to, or let me bring the s down here, is equal to z tilde ml by rho 0 c s. Okay. So if I do numerator, was something wrong, okay, minus, okay, this minus. So if I do numerator minus denominator, I get twice b tilde e to the power of j k l. If I divide by numerator plus denominator, I get twice a tilde e to the power of minus j k l, and then the same thing z m l tilde by z m l tilde plus rho 0 c s. Okay. So this is gone. Now this happens to be the reflection coefficient at x equal to L. Okay, and we will call it RL. So we will call it RL. Okay, so one should remember what we are saying, that A starts at x equal to 0, becomes A tilde e to the power of minus j k l, okay, and the B wave also comes, reflects, but B is 0 here because B is B tilde e to the power of plus j k x. So it is here reference to x0, it is B tilde only. Therefore at x equal to L, it is B tilde e to the power j k l. So it has reflected as B tilde e to the power j k l in a sense. So the reflection coefficient at the end is whatever is reflected, the wave reflected at the end by the wave that is incident on the end. Okay, I am sorry. This is the reflection coefficient. The B wave at the end is this, and the A wave at x equal to L, the end is this. So their ratio is the reflection coefficient. Okay, so that is this entity. Now so it's actually called the pressure reflection coefficient. So let's call it that way. It's called the pressure reflection, RL, and it is complex, is called the pressure reflection coefficient. Okay, that is this quantity. Now we can see what that means. Okay, if it happens, we'll just divide numerator and denominator by z tilde ml, so that becomes 1 minus rho 0 cs by z tilde ml, then 1 plus rho 0 cs by z ml tilde. Okay, now here if I take z ml tilde to be infinity, okay, then I get 1 then I get RL tilde equal to 1. Okay. So, this is the closed ended, this is the closed ended pipe. Okay, when RL is 1, this is a closed ended pipe. Now, when we have ZML tending to 0, okay, if ZML tends to 0, then we have minus rho 0 Cs on the numerator and rho 0 Cs in the denominator. So, this ends up as minus 1. Okay. So, this is called the pressure release condition. Okay. Here what happens is the incident is A tilde e to the power minus jkl and the reflected is B tilde e to the power jkl, and because of the minus 1 they are opposed to each other in sign, opposed. Okay. And therefore, the net pressure is 0. The net pressure at x equal to L is 0. That is why it is called the pressure release condition. Okay. So, now what do we have? We have B tilde e to the power of j k L by A tilde e to the power of minus j k L is equal to Z m L tilde minus rho 0 C s by Z m L tilde plus rho 0 C s, or if A is known, I can find B as A tilde e to the power of minus 2 j k L into this quantity which is R L tilde. Okay. It's nothing new if you remember the expression P x comma t is A tilde e to the power of minus j k x plus B tilde e to the power of j k x e to the power j omega t. So, now in terms of this, it is A tilde e to the power of minus j k x plus A tilde e to the power of minus 2 j k L R tilde reflection coefficient e to the power j k x. So, we had seen the interpretation of this expression. This is the travel back and forth to a point x from the left, and this is what is incident, and this is the effect of the boundary, and it interferes with the forward travelling wave. Okay, we had seen this before. So, now from here we can find just B tilde over A tilde, which is the pressure reflection coefficient at x equal to 0. is given by B tilde over A tilde is equal to e to the power of minus 2jkl into RL tilde, and we will call it R tilde 0. Okay. So, I will close the lecture here. We will use this notation to continue and solve the problem for 1D acoustics. Thank you.